Good morning to you all, and thank you so much for joining us today for our webinar, Bringing CCS Projects to Life in the Power Generation Sector. My name is Catherine, and I will be hosting today's session. We're so pleased to have you join us here today and share what we hope will be valuable information around the emerging landscape of CCS projects in the US and beyond related to natural gas and coal-fired power generation. So just a few little things before we start on how the session will portion. And then in the last 20 minutes, we will move into our Q&A. If you'd like to submit a question, you'll see the Q&A tab along the top of your screen. Just add your question where our team will be moderating submissions behind the scenes. Please note that today's webinar will be recorded as we plan to share it on our website. So on that note, if you would prefer for any question you ask to remain anonymous, you'll see that as a little toggle option on your screen. However, if you do choose to leave your name associated with your question, it will also allow us to follow up if we don't get to your question in today's session. So that choice is up to you. The chat function and the reactions functions have been disabled for today's webinar. So who are we? We are the International CCS Knowledge Centre based in Regina, Saskatchewan, Canada. We are a nonprofit organization dedicated to the advancement of large-scale CCS projects worldwide. And I will let our speakers explain to you what that means. So let's introduce them. With us today, we have James Miller, President and CEO of the Knowledge Centre. James provides strategic leadership in advancing the development of CCS technology as a key mitigation strategy for climate action. Under James, our engineers and analysts are building partnerships across industries to plan and develop large-scale CCS projects in Canada and around the world, enhancing and de-risking the investment opportunities. James has extensive experience in energy, industrial infrastructure, and public policy. James has served as a senior advisor in government and has led public affairs in the energy industry, including TC Energy. And most recently, before joining the Knowledge Centre, he managed public affairs for Paraday Energy and their CCS initiative. We also have Conway Nelson. Conway is the Vice President of Project Development and Advisory Services for the Knowledge Centre. Conway oversees our team of engineers and project specialists dedicated to advancing CCS technology across various industrial applications. Prior to joining us, Conway spent over 2 decades at SaskPower, where he managed large teams working on capital projects related to power generation, including new builds and CCS. So thank you both to James and Conway. James, I will let you get us started today.
Thanks, Catherine. Thank you, Conway, and really thank you everybody for joining in. When we came up with the idea to hold this webinar, we weren't sure how many people would join us. As of this morning, we had in the range of 150 people registered, so that speaks well to interest, and we thank you for that. And as well, we're hopeful that we can provide some value today, and we're confident that we can do that. So I'll tell you a little bit about the organization, just to build in on what Catherine said. Do another slide to give you a little overview of why we're doing this today. Conway will get into some engineering and technical information and expertise that we can provide. I'll rejoin and talk a bit about policy, the regulatory space, stakeholder relations, and then we'll wrap and look forward to your questions. So the International CCS Knowledge Centre, what is it? Well, as Catherine said, our real focus is on enabling CCS projects to be built, developed, and operate. That is really what we're all about. The impetus for the organization started in 2014 when the world's first commercial carbon capture and storage project came online. That's located in Estevan, Saskatchewan, Canada. And it came in 4% over budget, so we consider that a success. But more importantly, what it's done over the 8 years is it's allowed other clients that we work with the opportunity to learn the lessons that we've experienced in operating that facility. So as I said, it came on stream in 2014. The Knowledge Centre itself was struck in 2016. It was an initiative led by BHP and SaskPower. BHP provided the seed funding, SaskPower, the seconded employees, the experts, those who know CCS. And so it was struck, as I said, in 2016. So since 2016, a number of individuals spent the last few years basically. It wasn't cool to do so. But as all of you on the call have recognized, CCS has just taken a trajectory like this in the last few years and really is a technology that's necessary if we want to meet our global climate targets. So we're really proud to be involved in this space and really proud to help individuals move along their CCS journey. As mentioned, it was struck in 2016, and we would travel the world and talk about CCS. But one thing that we've morphed into, I'd say in the last 2.5 years, and Conway's going to speak to that, is we have used that knowledge gained over nearly a decade to help other companies out. And really, I would give your focus to the third bullet. In giving that knowledge to others, really we want to help companies and organizations lower costs, reduce risk, and improve operating performance. And really, isn't that what it's all about? So Conway will give you more information on that. Next slide, Catherine. So why are we here today? Well, like I think many of you, we weren't remiss to the announcement made by the Environmental Protection Agency in the United States on May 11th of this year, with the EPA stating it wants to regulate emissions from fossil fuel-fired power plants to the range of 90% reduction by 2035 for natural gas-fired facilities, coal-fired facilities in that 90% range by 2040, unless there is a plan to retire. So a large hill to climb. We're facing similar challenges here in Canada. And when we saw that announcement, we huddled together as a leadership committee and thought, how could we help if indeed this goes through? I think we're all cognizant of the fact that there may be a legal challenge. There may be a change in administration. Who knows where this will go, because the EPA has tried this before, as many in the US know. However, we felt, let's do a webinar. Let's let individuals know what we can offer, both on the side of if you're considering CCS based on the EPA's announcement, or if you're a company that is considering constructing a CCS facility based on, I would say, the Inflation Reduction Act that came into effect in August of last year, $370 billion of incentives. And I think it's really done a good job in the United States with the projects that are in development. So a little bit of a two-pronged approach there. A little bit on Canada. We want to focus in on the US because I think that's where most of our listeners are from. But just so people are aware, if anybody's listening in from Canada, we have the Clean Electricity Regulation. Essentially what that is a net zero electricity grid by 2035 and no unabated coal past 2030. So that could probably provide a webinar in and of itself for Canadian clients or Canadian companies interested in this, but we'll stick with more of a focus overall in CCS, and I'll pass it over to my colleague, Conway Nelson, who's our Vice President of Project Development and Technical Services. Conway?
Thanks, James. So as James said, we're really here to share what we learned from Boundary Dam Unit 3. And what I like to talk about with my team, people that were around through the development, the construction, and the ongoing optimization work that SaskPower has done in Boundary Dam Unit 3, is we share the owner's interests. We're really owners at heart, and we're trying to make sure that the owner's interest is served, and you have the most successful project you can, and you don't repeat some of the things that on Boundary Dam 3, I use this analogy a lot. If we had a time machine, we would go back and we would do differently. So that's really what we're here for, is to help you avoid some of those missteps and repeat some of those things we did that worked out quite well. So this chart just talks a little bit about the timeline of a CCS project. And as you're likely well aware, these are mega projects. You're talking billion-dollar scale investments. We lay out kind of a 6-year timeline here, and I think it's achievable, but it's aggressive. To do like a 1-year feasibility study, spend a couple of years going through a FEED study, getting ready for that ultimate final investment decision that happens somewhere between the orange box on the slide and the red box. And then once again, the red box, you're executing, you're building out your project. We think that's about a 3-year undertaking. Boundary Dam was less than a 3-year undertaking to do the construction. And then you're into the yellow box where you're talking about ongoing operations, optimization, different things you can do to improve performance. And fortunately for us, our team have been along the ride on the BD3 project through the purple, the red, and the yellow box on that project. And we like to bring everything we've learned and essentially share it with our clients so that they can have the most successful project possible. That's remains our ultimate goal. As you can imagine, most people are in the purple box. Not a lot of final investment decisions have been made. It's a very complicated mega project, and it doesn't generate revenue necessarily for your company. So there's a lot of uncertainty in terms of regulatory support and how to get to that final investment decision. But in terms of this purple box of getting ready for your final investment decision, there are a lot of things we can do to minimize the risk to the project and square away what the cost estimates are, understand that the technology is going to work, you're getting the best information into the hands of the licensors that are providing the technology, and you ultimately have a successful project at the end of the day. That's really the focus. That's where most people are. We're seeing people getting very close to the final investment decision side of things now, but the focus really is in the feasibility FEED phases of the projects. So this is Boundary Dam Unit 3, just an overall photograph of the site. And this is the power plant over here. This is Unit 1 and 2, had a common stack. They've both been decommissioned a number of years ago by SaskPower. Unit 3, Unit 4, Unit 5, and Unit 6 all share these stacks off to the side of the power plant. So Unit 3 is the plant that has the capture facility on it, and there's a duct that runs behind the plant and comes into the capture facility over here. And this is the capture facility itself, the regeneration tower. Sorry, the absorber towers are here. The regeneration tower is here. This is the compressor building. And out the back here, there's a little orange pipe that takes the supercritical or dense phase CO2 off to permanent storage, either with enhanced oil recovery or in a well that I'll talk as well. There's a lot of thermal energy that comes into and out of this process. So a large heat rejection plant was built here with a number of cooling towers over near the reservoir to deal with that too. So just gives you a picture of there's a lot of infrastructure, a lot of equipment that's required for these carbon capture projects. And so to date, the Boundary Dam 3 facility has now captured over 5.5 million tons of CO2 since 2014. It was designed for 90% capture capacity, and it's I'll talk a little bit more about some of the issues and how it's performing. So the Boundary Dam Unit 3 project, again, another photograph of the facility. Life extended the 45-year-old Boundary Dam Unit 3. And at the time of this project, people often ask, we get this question a lot, is why did SaskPower do it? Why were they first out of the gate? And at the time, this project was actually cost competitive with a natural gas combined cycle plant. So the FEED study was underway on a carbon capture plant back in 2008, 2009, investment decision kind of the end of 2010. At that time, natural gas prices were about $8 a gigajoule. So that really factored into increasing the cost of a CCGT plant, a natural gas combined cycle plant. There was a federal grant made available to SaskPower, so $250 million was available to offset the capital cost. And there was enhanced oil recovery off-taker agreement available as well, where the CO2 was actually producing some revenue for SaskPower to help offset the cost. So all those factors together made this project actually cost competitive for SaskPower when it was approved at the end of 2010, early 2011. As James mentioned, it was actually a two-part project. So the cost estimate was $1.5 billion. The CCS plant was about $900 million, and that portion of the project was over budget by about 4%. There was a larger cost overrun on the overall project, but the majority of that actually came in the power island upgrade, which is a little bit surprising because SaskPower has done those sorts of projects before, but that is where the majority of the cost increases came in. So the commercial operation of the plant started October 2014. So it's been operating now for almost 9 years. So you got that little orange pipe coming out the back with the 2,500 PSI dense phase CO2. What do you do with it? So there are two things that SaskPower does with their CO2. First, the majority of the CO2, about 90%, gets pipelined to the Weyburn-Midale oil field, which is operated by Whitecap Resources. That field has been doing enhanced oil recovery with CO2 since the early 2000s. So they've got over 20 years of experience of using CO2 to extract oil resources and re-inject the CO2 that gets produced with the oil. And they've been operating for, again, since over 20 years, and they've safely stored over 38 million tons. And I think that number is a little bit low. It's a bit of a dated number. It's probably 39 or 40 million tons by now. The other path that this SaskPower CO2 takes is the Aquastore well. So there's an Aquastore well. That's what the photograph is there, the wellhead of the Aquastore well. And it's located essentially on site. It's about 3 kilometers as the crow flies from Boundary Dam. And it's 3.4 kilometers underground, and it's storing CO2 in a saline aquifer. So it's one of the deepest wells in Saskatchewan. And it's very much been a research well. So it's heavily instrumented, a lot of geophones, a lot of monitoring wells to understand what's happening with that plume when it goes in the subsurface. There's been 4D modeling. People have come from all around the world, geoscientists, to look at this facility and understand what happens to CO2 in the subsurface. So it's quite a valuable resource that SaskPower has. And a lot of people come specifically to visit the Aquastore well too, as they're trying to understand their geology for storage. So this is a diagram of the CCS process itself at Boundary Dam Unit 3. I won't get into too much detail, but at a high level, essentially you start with a flue gas source. And in this case, SaskPower burns coal, they produce steam, the steam produces electricity. The byproduct of that is flue gas that has fly ash in it. So the first thing that happens to the flue gas, it goes through a dust collector, which is a dry electrostatic precipitator. It captures 99.5% of the particulates that are in the flue gas and attempts to clean it up well enough to get ready for the capture facility. The next thing that happens with the SaskPower process, and I'll speak to this one a little bit, is heat recovery. The flue gas coming out of the plant is quite hot. It's about 350 or so degrees Fahrenheit, and it needs to be cooled down to about 160, 180 degrees Fahrenheit for the capture process to work properly. So there's a lot of energy. So you take that heat out of the flue gas, and there's a lot of energy you can potentially do something good with. And one of our engineers on our team, he was part of the study that had a look at what you could do with that energy. And it actually made sense for SaskPower to take that energy, take it back into the power cycle and offset the first stage of feed water heating, so the water that goes into the boiler to produce steam. And long story short, they were able to gain about 4 megawatts of electrical generation on a 150 megawatt unit by capturing that energy and putting it back into the plant. So thermal integration is always something to think about. This system over here, this is an SO2 absorber, SO2 stripper, and an acid truck. So one of the other things that SaskPower does, they're able to sell some acid from the sulfur that they remove from their flue gas. They remove it in such a way it can be converted into sulfuric acid and sold as a byproduct. This is something that I don't think we'll see in a lot of other capture facilities. A lot of coal-fired power plants have, wet scrubbers, dry scrubbers, something else to take care of the sulfur. But in this case, SaskPower didn't. So this was an opportunity to use 2 amine systems at the same time. As you're making the step to an amine system, it made sense to do one for sulfur, one for CO2, and sell a byproduct for acid and use, offset their own cost for acid. This is the heat rejection equipment over here that I mentioned in the previous diagram. Now it's rejecting heat from a number of different sources throughout the process, but for the purpose of the picture, it's just shown connecting here. The heart of the process is the CO2 absorber and the CO2 stripper and the compressor. This is where the amine comes into the stripper from the top, flue gas from the bottom. Flue gas reacts with the amine, the CO2 gets extracted, and then clean flue gas comes out the top. So with much less CO2, the system's actually capturing anywhere from 90 to even up to 95% at times of the CO2 that it's able to treat, of the flue gas it's able to treat today. The amine then goes over to the regenerator where it's heated. The heating process drives off the CO2. So what's called a lean amine comes out the bottom of this regenerator tank. The CO2 comes out the top of or it's a regenerator or a stripper tank, comes out the top, and then that CO2 gets dehydrated it gets compressed into this supercritical dense phase, about 2,500 psi, give or take, or 170 bar. And then it gets pipelined over to Weyburn. That's about a 70-kilometer pipeline to Weyburn, and where it gets ejected into the oil formation about a mile below the surface and used for enhanced oil recovery. Or it can go to the Aquastore well, which is much deeper, that 3.4 over a mile down into the surface. So that's kind of it in a nutshell. And what happens over here in the amine. So the amine, when the CO2 gets stripped off, it's called a lean amine. Then the lean amine comes back over here. It captures CO2, becomes a rich amine, and it just sort of circulates back and forth. This is where some of the particular challenges that have plagued Boundary Dam really come to surface, because this amine just keeps kind of going around in circles. I wanted to point that out, and we'll speak to it in some of the subsequent slides here. So successes and challenges. With any major projects, you're going to have challenges, and BD3 had its share for sure. And that's what we spend a lot of time talking to people about at things like our workshops that we do. But some of the successes, if you think back to the timeline, this project was approved at the end of 2010, early 2011. So there wasn't a mature market where people were selling guaranteed performance for a capture system on flue gas for post-combustion. So at the time, this is actually a 7,001 scale up. The amine process that's used was understood more so from the oil and gas sector for gas sweetening, but it hadn't been used in this application. So the company that SaskPower ultimately worked with, this is a massive scale up for them. So you can imagine the number of questions that's asked by board of directors, or in this case, the government of a province, before they invest over $1 billion in a project. How do you know that the scale up is going to work? And that was a success. The system does work. The scale up was successful. I talked a little bit about thermal integration already, so I won't go into that, but it's important to make sure on any project you look for opportunities to do thermal integration. Just minimize the cost of the energy that's required for these amine post-combustion processes. Connected to that was the flue gas cooler, and that's what these photographs are of. So SaskPower knew they wanted to extract this energy out of the flue gas, and spent a lot of time understanding what material would be compatible with the flue gas. It has acid gases in it. When you cool it, those acid gases condense out and they land on these heat exchanger tubes. And this is a failed flue gas cooler that the team went and saw over in Asia. And you can see any sort of metal, what they really concluded, any sort of metal wasn't going to stand up to this service. So we ended up selecting a Teflon tube heat exchanger, which has worked very well. Not very good heat exchange characteristics, but it can withstand the acid, and it's worked really well again for the up to almost 9 years of operation here. Over on the challenge side, so if we were to characterize the challenges kind of in one word, that word typically is fly ash. It's that particulate buildup. As I mentioned, the ESP captures 99.5% of the fly ash that's in the flue gas, but that last 0.5% gets in the system. It stays in the system. It circles around. And you can see how it fouls some of these demister plates here. You can see what it can do to some of the packing. In addition to the fouling characteristic of the fly ash, so the fouling just makes it really hard to push the flue gas through the system. And what SaskPower has found over time is they're unable to push the full flue gas flow through the capture plant, largely due to the fly ash fouling. And so a slipstream of the flue gas actually goes up to the stack. And the majority of the flue gas gets treated by the capture plant, but not 100% of the flue gas gets treated by the capture plant. It just simply can't be pushed through the system with the fouling they've seen from fly ash. In addition to the fly ash fouling, there's been recently an organic growth that's occurred, and I don't have any photographs of that. It's honestly a little bit disgusting, but some of the organic growth that's showing up in the absorber is causing additional back pressure and making it challenging, again, to put the full flue gas through the capture plant. What SaskPower is able to put through the capture plant is being captured at 90 to 95%, but they can't put the full flow through. Amine degradation. This is always a challenge. We want the amine to react with CO2, but a number of other constituents in flue gas can react with the amine. They can degrade its ability to react with CO2. This is something that was a challenge on BD3. SaskPower thought they had it understood. They thought they had their flue gas characterized, thought they understood what was in their fly ash. But there are some things that are causing problems in terms of amine degradation, and it's important to think about that in your early stages, your feasibility stages, your feed stages. That ties nicely to the next bullet on there, flue gas characterization. So if you take one thing away from what I'm going to share today, flue gas characterization is probably the thing. everybody measures their flue gas today. We all measure how much particulate, we measure how much SOx and NOx are in the flue gas, mercury in some cases in the coal-fired power sector. What we don't do is measure it to a level where it's understood well enough to now be an input into a sophisticated chemical process. And that's a big step. That's something that really needs to be understood well. We've worked with a lot of clients to help them understand the importance of characterizing their flue gas and how to go about it via stack testing or analyzing their SEMS data, various ways to understand what's in your flue gas. I spoke a little bit about the reduced capacity, and the reduced capacity is a big challenge caused by fly ash fouling, and there's been an organic growth that's shown up in the absorber towers as well that's caused some challenges. There were also some economic factors early day that aren't a factor anymore, but there was a disconnect between how much CO2 SAS Power could capture and how much they were being compensated for with enhanced oil recovery. So the system wasn't run as hard as it could have been the first number of years because there wasn't really an economic driver. It made more sense for SAS Power to produce more electricity than capture more CO2. So some of the things that our team talked to people about, and James would have mentioned this up the front, but really lessons learned. Our team's all about lessons learned and bringing them to people and making sure that they apply these lessons learned to reduce their risk, lower their cost, and improve performance of their projects as they move forward. And again, our focus is on successful projects. That's really what my team looks for, is making sure the projects are as successful as they possibly can be. We've applied these BD3 lessons learned across a number of sectors. Obviously, power generation, that's the focus of today. We've also worked with people in the cement, mining, fertilizer, oil and gas, steel, and hydrogen production. Anything that's a post-combustion carbon capture application, what we learned about it on Unit 3 being one of the world's first is directly applicable. So some of the key things we talk to people about are technology suitability and maturity. So this conversation has really been about amine post-combustion. That's the system we have at Boundary Dam Unit 3. That's what we see as the most mature technology today. Vendors have this equipment available. They will commercially guarantee. It's now 95% performance people guarantee in terms of capture rates. But there are other technologies that are evolving. There's cryogenic technology, there's solid sorbents, there are membrane technologies. These things are all coming. They're getting more and more mature. But what we find when people are considering, again, these billion-dollar investments, they're more apt to be a little bit risk-averse and go after the technology that's been more proven. I think a time will come when there will be more options available to people. So if companies either have a higher risk tolerance or if they have a little more runway before they have to do something, it's more important to look at some of these emerging technologies as well. And that's something we've advised people on. Then once you do select a technology, it's narrowing down which technology provider is actually the best fit for your flue gas, the best fit for your company, all those things. And those are some areas we've helped clients with as well. There it is again, flue gas characterization. Pilot testing kind of goes hand in hand with that, but flue gas characterization, be it stack testing, SEM data analysis, or the next step becomes pilot testing. So if you really want to understand what's in your flue gas and how it's going to interact with the amine, is you actually bring a skid to site, you run the amine through, you run the flue gas through your skid, have it interact with the amine in the skid, and you get a much better picture of what will really happen on the big picture. So a few things you can do to mitigate your risk going into those final investment decisions. Thermal integration, I talked about this one already as well. It's very important to consider thermal integration when you're looking at a carbon capture project. A lot of energy required. If you can do that in a smarter way and more efficient way, you can save money. Variation in understanding. There's a real diversification of skill sets in some cases, and SAS Power was a prime example. So SAS Power had a lot of people that are really good at turning kind of crummy lignite coal into electricity. They were afraid of this chemical process. They didn't understand chemistry. What SAS Power did is during the project, well before completion, a couple of years before, they started bringing operators in to build a transition operations team. They actually built a fully integrated simulator to train operators. They brought in chemistry training for their operators that are going to be part of the capture plant. And they actually did a really good job of being ready for operations when the system was up and running. But it takes a lot of effort. It takes a lot of resources, and it's not free to get up that learning curve and understand how to operate a CCS plant. So lastly, just some of the technical support things that we provide for projects, tours and technical workshops. So we've done a number of technical workshops with teams where we've gone through the archives of the Boundary Dam 3 project, and we built about a 450 slideshow, and it's quite daunting. We'll spend 1 or 2 days with a team of engineers, and we'll tour Boundary Dam 3. We'll walk through all these lessons learned in a lot more detail than I covered here quickly today. But they're actually my favorite thing that we do here at the Knowledge Center. We come out of those 2 days kind of exhausted, but it's really refreshing to see people saying, you know, I hadn't thought of this before, I hadn't thought about that before, and just seeing the light bulbs go on a little bit. It's really fun for my team to do those workshops. Flue gas characterization, there it is again. So we have some thoughts on stack testing recommendations, different levels of granularity to go to with stack testing, what people can do. We've helped people analyze their existing emissions data from their SEMs to see what we can draw out of it for conclusions in terms of variability of various flue gas constituents. We've done some statistical analysis on that side. Pilot testing, again, this is kind of flue gas characterization, the next step. And we've helped people set up their pilot testing programs and oversee some of the work that's happening there, some of the data analysis as well coming out of the pilot skids. And then the technology selection, and I talked a little bit already about the emerging technologies. What's the right technology? Who's the right partner for you? Even the project execution considerations. How do you set this up? Do you want a single EPC? Do you want to take control of it as your own company and break apart into piecemeal contracts to execute the projects? We've spent a lot of time talking to people about those things as well and helping to set up those structures in terms of what the market will bear today around risk sharing in terms of EPC contractors versus owners, and even the labor market, the supply chain. All those considerations are going to make these projects challenging over the next number of years. So we do help support people as they're grappling with those questions as well. And with that, I'll pass it back to James.
Thanks, Conway. I was so enraptured with your presentation, I forgot to turn my camera back on. So hi, everybody. And great overview by Conway on the technical side. And we really look at the CCS journey as the technical piece, the engineering piece is so key. But there are other elements that if you don't get taken care of, you don't have a project. And that really is where we can offer, and we have been since inception, that strategic guidance and support on projects. We do that in a number of ways. You know, everything starts, of course, as we all know, with your strategy development. What is your approach in this area to your stakeholders? So we can look at customizing that roadmap for full chain CCS project development, strengths, weaknesses, opportunities, and threats. Thing that can trip you up if you don't deal with a stakeholder's concerns, or you haven't even analyzed that stakeholder is out there and has a concern. That's an element that can trip you up, and that's something that we've done for clients on a number of bases. And then there's the business case development, of course, that we can support on. Policy and regulatory, I mean, that really has been the focus globally. I think when you look at the United States, and I mentioned it earlier, with the introduction of the IRA last August by President Biden, you've got that certainty of $85 a ton if you're storing the CO2 underground for 12 years. We're looking for that same certainty in Canada. The legislation has been proposed. It's not yet reached our parliament, so it's not yet passed. There's also the issue of CCFDs, or carbon contracts for difference, something that we're working through here. But really what we've done for clients is help them navigate this policy and regulatory space, whether it be different provinces or even in the United States. We're International CCS Knowledge Centre, but a Canadian organization, yet we were involved in the development of the 45Q in the US and also in Canada that, as I said, is receiving a lot of focus right now, the investment tax credit. We were involved in that back in 2020, 2021. So again, we can offer support on the policy and regulatory side, the navigation of government reporting, and that's going to come in a large way, funding applications and publication of policy briefings, white papers. That really gets into putting out the information that is necessary, the facts that CCS is a safe, proven technology and something that we produced in the past and will continue to do so in the future. The other thing before I get into stakeholder engagement and communication, something that we're really proud of is we're in the midst as we speak of setting up the world's first CCS knowledge sharing hub or exchange. We've been working on this concept for about a year now. We received some pilot funding from the government of Alberta. So we have sleeves rolled up as a team. It's one of our core focuses. And the way we look at it, and I think it's thematic of what we talked about over the last 35 minutes thus far, is you need to share knowledge if you're going to be successful. But most importantly, I would say for boards of directors and senior management teams, when they see your business case, they want to know that you've de-risked the highest of your ability. And so the ability, again, to share that knowledge from projects such as Boundary Dam, Shell's Quest project, Alberta Carbon Trunk Line, the largest carbon line in the world. That's the direction we're moving in. And when we came up with the idea for this concept a year ago, we tested it with some international organizations, including the Global CCS Institute out of Melbourne, Australia, and the UK CCSA in the United Kingdom, and both were supportive of us going down this path. So we're really excited about that, and we're driving that forward. When I get into stakeholder engagement and communication, something that's near and dear to my heart, and I really believe that if you don't have public acceptance, ultimately you don't have a project. So we're really high on sharing factual information, being transparent, getting the facts out there. And the ability that we have, maybe that can be different than the proponent. The proponent has a vital role to play through open houses, through interactions with stakeholders, local government officials, state officials. Of course, companies know that well and do it well. But one thing that we can provide and layer in on top of that is the knowledge and expertise that we've gained since 2016 in understanding the CCS space, talking about lessons learned, but then also talking about the factual aspects around a CCS. And Conway mentioned one fact that not a lot of people know. Sometimes CCS is criticized that it's not proven. Well, when you look at Weyburn-Midale, and in the range of 38 to 40 million tons safely stored without incident, people's ears pick up. And what Aquastor has done since 2012 in monitoring the plume, they have that data. They're willing to share that data. So there are some great facts out there that demonstrate that CCS is safe and proven. We like to talk about it. It's something that we've been focused on for a number of years, as I say. And you see those two words that are highlighted in the slide: being objective, being neutral, being that third party. We can do. The other thing that we can layer in, there are some of us on the team that experienced issues in the United States going back to Keystone XL, and some of the issues that were raised and some of the concerns. And so we have a familiarity with what has occurred in the U.S. And I think for those of you who have monitored occurrences in Iowa, North Dakota, South Dakota, even in recent weeks with pipeline permits being denied for one of the large-scale projects south of the border, you see what I'm talking about is not everyone is enamored with CCS. Some would not like to see it occur, but I think we have the knowledge and ability to help someone navigate through that space. And again, all based on neutrality, objectivity, sharing the facts, and maintaining that as an organization. So if you go to the next slide, please, Catherine. This is just a shot, I think, that demonstrates what I'm talking about with some of the pushback that's occurring. No carbon pipeline on the side of the semi-trailer, and this is a shot from Butler County. Unfortunately, there are some out there that are putting out misinformation. We like to focus on the facts. We want to do that and are doing it really on a daily basis. If you look at what we're putting out in social media, some of the publications that we've done and will do, So something, again, that we're focused on. And really, when you look at that final quote, it's about honest engagement, sharing knowledge, really key to improving CO2 pipeline safety. So I can't say that enough. Engage with your stakeholders. Do it early. Don't wait for the issue to arise. Do it before the issue arises. And build that trust. Be transparent. Share the facts, and I think you'll be on a good path. Next slide, please, Catherine. So just to give you a sense of who we've worked with, we're pretty excited, of course, about everyone. But for those of you who are from the US, particularly excited with Calpine, Lignite Energy Council, and Rainbow Energy Centre, because as Conway said, something that he really enjoys, and I've been on the tours as well, there's nothing like having an organization see, smell, touch Boundary Dam. It's the size of 3 US football fields, tops out at 8 stories high. It's something to behold. And when you tour it, you really get a sense of what it's about. And it's such an interactive session for companies that have come up and experienced the tour. Calpine, for example, one of the largest, if not the largest thermal utility in the US, sent up a group of executives. I think they were impressed to the level that they then subsequently, 2 or 3 weeks later, sent a team of 25. Same with Rainbow Energy Centre and Lignite Energy Council. So it's just really fascinating for us to see that engagement when you tour the facility. And I think over the years since 2016, we've had representatives from 38 countries globally. So it's almost like we have someone out there every week. So it's a cottage industry in and of itself. Other organizations, you see Pathways. It's the 6th largest E&P companies in the province of Alberta. They're looking at a $16.5 billion project. So we're doing some work with Pathways across the ocean in the Humber Hub in the UK, P66, VPI, also in the UK, SSE. There's Humber that I mentioned. And one thing Conway touched on, but I think it's so vitally important for the work that we've done, is yes, we started foundationally with a coal-fired facility, but we did a pre-feasibility study for the Heidelberg cement facility in Edmonton, Alberta, Canada. We worked with other cement organizations, mining companies, steel companies, fertilizer companies. So what we found is the lessons learned from Boundary Dam are very applicable to all heavy emitters. And we all know that in hard-to-abate industries such as steel and cement, you need to use CCS if you're going to control your emissions. So maybe I'll just end on a quick little testimonial, because, you know, it's one thing for Conway and I to talk about our bona fides. It's another thing to see what people have to say. So I'll just end on this. It's a nice tight one from James Beresford Lambert from VPI in the UK. And James shared with us, and we have a really good relationship, ongoing one with VPI, quote, "The candid and open sharing of issues and how you, Knowledge Centre, resolve problems through design, construction, and operation was beyond our expectation. I'm sure we'll face our own issues, and we all have, and we all will, and unknowns, but for sure, we can reduce our risk based on our interaction with the Knowledge Centre." And maybe I'll end there and pass it back to Catherine. Thanks, everybody.
Great. Thank you very much, James and Conway, and thank you to all of you who have been submitting questions. Just a reminder, if you'd like to submit a question for the Q&A, click on the tab on top of your screen. Questions are selected and moderated by our team behind the scenes. A reminder as well that you can choose to remain anonymous or have your name visible so that we can follow up with you if we don't get to your question today. We've compiled some great questions here, so let's get started. First one that I can answer quickly: will this recording be shared with us later? Yes, we hope to post this recording to our website, so there will be a follow-up email coming from me after today's session. Next, and I think this question will probably be for Conway, what is the conversion of 90% to tons per gigawatt hour at BD3?
Yeah, I can handle that one. So the unabated emissions from BD3 are about 1,000 to 1,100 tons per gigawatt hour. So if you capture 90% of that CO2, you're down into the 120, 130 sort of range. And as I mentioned, SaskPower isn't able to capture the full flue gas flow rate due to fouling, be it fly ash or be it this organic growth. But that's what the conversion rate would be. It'd be, 1,000 to 1,100, call it 1,050, take 90% of that out.
Great, thank you, Conway. Probably another one for you. Do you know if Sask Power will be adding CCS to any other units? If no, why not?
Yeah, so that's a question for Sask Power, and Sask Power has been looking at what they need to do for carbon capture, and we know that they're looking more seriously at carbon capture on their combined cycle gas turbine plants. There are no plans in place today to do carbon capture on conventionally fired coal-fired power plants, but we know there is a big focus on carbon capture on their combined cycle gas turbine plants. Why not is not really a question that I can answer, but I know Sask Power looks at a number of options, including small modular reactors, renewables, and CCS on gas. Those are kind of the big things that Sask Power is looking at today.
Great, Conway. I expect this one is for you probably as well. BD3 CCS plant also has SO2 removal unit. What is the cost of only CO2 capture unit excluding SO2 removal unit?
So I'll answer that by saying Sask Power is very gracious in terms of sharing a lot of information with the Knowledge Centre. The Knowledge Centre can share with other people to help reduce risk on these projects. That breakdown of capital costs is not something that Sask Power is willing to share today. So unfortunately, we can't give you that breakdown of how much of that 900 million you could take away if you didn't have to do the SO2 system. But know that the SO2 system is significantly smaller than the CO2 system in terms of the size of the equipment at site. So it's certainly not half, and then the compressor is a big portion of the cost as well. So fortunately, I can't give you a direct answer on that one.
Thank you, Conway. Is the flue gas characterization suggestions available for the public?
We do have a version of the flue gas characterization document put together that we'll happily share with anybody. So just reach out to us and then we'll have a conversation. We can talk to you about that, the 3-stage document that we put together for sure.
Yes, pinned at the top of the Q&A is our info@ccsknowledge.com website. So if you have any questions that we don't make it to today, please feel free to reach out to us there and we'll have someone get back in touch with you. Probably another question for Conway. Does BD3 CO2 capture unit have emissions permit for amines, nitra plus nitrous amine emissions?
Yes, and it was very hard to come by, and it's only for the Boundary Dam 3 project. But this was something that took a lot of effort for Sask Power to educate the regulator about air emissions coming out of the back end of the capture facility. So much so that they actually went to Norway to find a similar regulation and bring some of that information back. Later on, characterized the toxicity of the actual nitramines, nitrosamines, and amines that could and are to a certain level coming out of the stack of Boundary Dam Unit 3, and understood the toxicity was significantly lower than the guideline that was set. So it's quite a safe guideline, but more work needs to be done in this area. As you may hire every technology licensor, they've got a slightly different formula. So the nitrosamines and the nitramines, the various things that are emitted into the air look different, and they have different levels of toxicity. So everyone has to be looked at a little bit differently. So it's a big challenge, and it was a big challenge for Sask Power. There are things that we can share that sort of were learned going along that process, but it's not a fast process. There's no regulation that says thou shalt be below X level of nitrosamine emissions. It's not that simple.
Thanks for your patience with my pronunciation of the chemical words. I'm clearly not the chemist on the call. Next question. What impacts to the process are expected when alt fuels or natural gas blend is later mixed with hydrogen in an operational carbon capture?
So I'm not sure if I understand the hydrogen mixing piece. Certainly, we've looked at situations where people have blended various fuels or blended various flue gases together, be it alternative fuels with natural gas or coal, and what will happen to a carbon capture facility if it has to burn various different fuels. So hydrogen production doesn't produce CO2, so you typically don't blend, you typically don't do a CO2 combustion, and if hydrogen is using an SMR process, there's some combustion gases which kind of get treated similar to post-combustion. But Blending flue gases can be done. James referenced the project we're working on with Heidelberg and Edmonton, and they're looking at blending their cement kiln flue gas with the flue gas from a combined heat and power plant, which is making their system more economical, more efficient in terms of how they're using the energy. So they've got gas-fired exhaust stream combining with the flue gas exhaust stream, and they're capturing both in the same facility. So that can be done. It's more complicated. You have to do a little bit more analysis, but it certainly can be done.
Thank you, Conway. One more for you, and then I think I've got one for James here. First for Conway, can you talk more about solvent degradation challenges faced in BD3?
We could talk for hours about solvent degradation challenges. I'll just hit a couple of things that SaskPower found. One was their fly ash. SaskPower understood their fly ash very well and knew what the chemical composition of the fly ash was. But what happens is 99.5% of fly ash gets captured by the ESP. The 0.5% that gets through has a slightly different chemical composition. And it's not actually benign in terms of interacting with the amine, as was thought based on the bulk composition chemistry of the fly ash. So that fine particulate of fly ash is actually causing some amine degradation reactions. There have been some other things they found in terms of iron in the flue gas is causing some degradation reactions. Obviously, everybody knows sulfur, NO2 are bad actors, but they did treat those up front, so they haven't been major issues. It's been that fly ash issue. The iron has also been an unexpected challenge, and a number of things. And then this is a deep topic.
Thanks, Conway. A question for James. Is there a reduction on tax or any incentives from the government for the captured CO2 at BD3?
Is there a reduction in tax? Sorry, I didn't catch that.
Is there a reduction on tax or any incentives from the government for the captured CO2 at BD3?
Conway, I think I'll give that one to you.
So there is. So coal-fired generation in Canada, there's a baseline level of allowable emissions you can emit before you attract a carbon tax. And Boundary Dam Unit 3 gets below that level. So SaskPower has an equivalency agreement where credit is given for how much they're getting below that level when they capture BD3, and it can be applied to the other units to offset some of the carbon tax that's attracted.
Thanks, Conway. Another one for you, I think. Will 30 tons per gigawatt hour be achievable? And if so, when and what technology?
That's a really good question, and that's straight out of the Clean Electricity Regulation. So 30 tons per gigawatt hour is achievable on natural gas. Natural gas units emit about 400, call it 380, but I like to use a rounder number of 400 tons per gigawatt hour. Suppliers are guaranteed 95% performance. So in a perfect world, 95% capture out of 400, that'll get you down to 20. So to get to 30, you need to be at about 92.5% capture. The challenge comes in with the ramp up and ramp down nature that natural gas units often have. You have less efficient capture when you're moving up and down. You may have to run your capture plant a little bit harder to make sure you're capturing at periods where the natural gas plants are running a little bit lower. So theoretically, it can happen. Practically, it's a challenge. And we've talked to our friends in the electricity sector, and they have a lot of questions about that number as well. But on paper, it can work.
Thank you, Conway. Another one for you. Is the emission permit for BD3 CO2 capture unit available for public?
No, that permit is not publicly available. Yeah, the short answer, I guess, it's not publicly available. If you have questions about air emissions, we can have a conversation if you reach out to us.
Great. So that's all of the questions that we have on our queue. I'll just open the floor to the two of you if there are any final comments you'd like to make before we wrap up. Nope. Okay, great.
Oh, I was being the polite Canadian. I'll let Conway go first, and then I can say a couple words. Conway,
so for me, I think, I talked a lot about it during my talk. I think if you take one thing away, think about the flue gas characterization side of it. That's the thing that can be the biggest issue. If your process isn't compatible with your flue gas because you didn't understand it properly, that can cost you a lot of money down the road. There are a number of things that you should think about, but that's one of the key ones, I would say, in our experience and our conversations with our clients.
Yeah, and I would just leave everyone, and it doubles down on what Conway has been saying, and thematic to his points is be prepared. Don't do what we do when we receive some phone calls and potential clients will say, what technology should we use? And we'll say, hang on a minute, that's probably question 9. The first thing that you need to do is do a project analysis to see if it's even viable. And, we like to say we're going to tell potential clients what they need to hear, not what they want to hear. So we are that true owner's engineer, but also that true independent thought leader in really helping companies achieve their CCS journey, whether it be on the technical side, whether it be on the policy side, whether it be on the stakeholder side, because I think the vast majority of people on the call, we just want to see this get done. Yes, there are hurdles, but the benefits to this are multiples based on achieving targets. We have a carbon tax here in Canada that's looming at $170 a ton by 2030. So everyone and every company is facing their own challenges, and essentially through what we've learned since 2016, we want to be of help to navigate those challenges.
Great. Thank you very much to both of you. I think that marks the end of our time here today. On behalf of the Knowledge Centre, I'd like to thank everyone for participating. Keep an eye on your inbox for an email that comes from me later today, which will have a PDF copy of today's presentation and hopefully the link to this video, as well as some contact information if you are interested in learning more about taking a tour of the Boundary Dam 3 CCS facility, potentially attending one of our workshops, or just chatting with someone from our team. It will also have links for you to sign up for our newsletter and to follow us on LinkedIn and Twitter if you don't already. Maybe just remember to take a look in your spam filter, as lots of emails from me get stuck there. So again, thank you so much for joining us today, and we look forward to seeing you next time. Thanks everyone.
Everybody.
Thanks, everybody.
Bye-bye.
Bye-bye.